上次讲到哪边？我上次讲到哪边？我们上次讲到哪里？对，你不知道。第几页？没有人提。没关系，没关系，我们 4.5 会讲。
学术上到array，上到 array，
上到 array，OK。Okay. Suppose we have seen the so-called for statement. For statement. In the for statement, we have a parenthesis and a pair of the bracket. And within this for statement, we have two semicolons. Okay, and this one. And divide this small this parenthesis into. Okay, and this is two. This is for statement. And see, we have. Okay. So this is a for statement, and following the keyword for, we have a pair of parentheses and then a pair of big bracket. Okay, and within this small parenthesis, we have a two semicolons. This parenthesis will be divided into three parts. This is first part. This is first part, second part, and the third part. And the first part is initial, which means at the beginning of the first statement, the program will execute this first part. And then the second part is a condition. When condition is true, and this pair of big bracket will be executed one time. So you can put several C statement with this pair of big bracket. Okay, and you will be execute line by line until the by big bracket. And after the last statement is executed, you will go to the third part of this small parenthesis, which is called stepwise. And in fact, this is also an expression. This is also an expression. This is also expression. So in the textbook, you can see when textbook call it expression 1, expression 2, expression 3. Okay? Now, a common for statement. Let's use this one. A common for statement we will see is let's take a common for statement is when you know exactly how many times the statement within this bit bracket will be executed. Okay? Now suppose we want to do a summation of 1 plus 2 plus 3 plus 4 plus 5 plus plus 10, and we want to know what is this sequence of addition. And we can use for statement to do the job. But in your math class in high school, I believe everybody know the formula for this kind of sequence addition is the first term plus the last term, okay? First term plus last term divided by 2. And at times, number of terms, which is 10. And we know this is 55. Okay? But in computer, we can do is using for statement. So I is available that represent the number we are going to add in the next iteration. To execute the statement within this bit bracket is called an iteration. It's called an iteration. Okay, or is called an iteration or a loop. Okay, so here we have a small parenthesis. We use 2 semicolons to separate into 3 parts. And the first part is initialization, is initial. So we initial the I variable into 1, okay? Because we are going to add the first value, which is 1. And then the second part is condition. And this condition is I less than equal to 10, because the last number we are going to add is 10, okay? Now, each time we add a variable, we accumulate a variable, we have to increase the variable by 1. So in the third part, we use I++, okay? In here, there will be no difference between I++ and plus I, okay? Because in the statement here, there's no action, no consequence of taking the value of variable I. So in here, I have to emphasize, just in here, you can use plus I or I++, okay? But normally, most people use I++, okay? Don't ask me why, just most people use I++, okay? That's the reason we call a language. We call language, okay? We have C, and about 10 plus years later, we have C++ language. This is a language name. Okay, as I mentioned before, C++ is a superset of C. So the inside is C, and then the outside is C++. So everything the syntax, every syntax of C can also be used by C++. So C++ compiler can compile C language, which is just what we are doing right now. We are doing in this semester. So in fact, we are using C++ compiler, okay, in this semester. But we only use the feature of C. Okay, we teach C. So in your program, you should not have a file by something called the extension name. You should not have a CPP as an extension name because file with extension name of C++ means it's a C++ source file. But in this class, we teach C, so the extension file name is C. Okay, don't use this one. Please use this one. Okay. Now, come back to our example. Is come back to our example. With a mouse. A mouse is gone. Okay. Where's my mouse? I don't have a mouse. Okay. Now we have the sum plus equal to I. Okay. We just here's my mouse. Okay. Now it means we take the value of variable I and add into variable sum. Okay. Now in the first iteration, the variable has value of 1, and in the next one, the variable of I has value of 2. So this is just like this fourth statement is just like we are adding 1 plus 2 plus 3 plus 4 plus 5 plus until 10. Okay. Now outside fourth statement, okay, we have the sum of the value, and also before the sum, before this fourth statement, we reset the variable sum into 0. Now we have another way to do this initialization. As I mentioned before, for fourth statement, we use 2 semicolons to separate into 3 parts. And the first part we call it initial or initialize. But in this initialization, okay, we can have multiple statements. We can have multiple expressions and separate by comma. Okay, so for example, we can have this a statement like this. Okay, semicolon. We can, in this first part, we can write I is equal to 1 and a comma sum is equal to 0. Okay, we use comma to separate different expression or different sub-statement in for statement. Okay, so in here we do this. We instead of initialize sum into 0 in here, we can do here. We use comma and sum equal to 0. Okay, so doing this, we have exactly the same result. Okay. Okay, now we see sum is equal to 1. Obviously, we made mistake. Okay? So where is mistake? Because the condition, okay, it should be I less or equal to 10. Okay? It's now 1. Okay? So, we compile again. Execute. Now the sum is equal to 55. Okay? Now we say this example. Say this example. Zero 1A. Okay. Suppose we are not to set 0. Set sum to 0 here. We do it outside. Sum equal to 0. Okay. We got identical result. Okay, 55. Okay. The difference is we initialize sum inside or outside of for statement. Okay, but they got the same result. So we say this example. Now we call it EX10 S01B. Okay. Now, what I'm going to do now is introduce so-called nested loop. Nested loop. Put it in simple way is within a loop statement, we have another loop statement. So, for example, we have a for, and then we have a big bracket. Now, within this big bracket, legally we can put several statements in here, inside this big bracket. When all these statements, including another loop statement. For example, we can put another for within this big bracket. So we have a for, okay, and then a big bracket here. And this part of the statement will be executed how many times? It will depend on how many times this for statement will be executed. Okay, and no, not here. How many times this big bracket will be executed, and how many times this big bracket will be executed. Okay, so let's see an example. Next example is 9 cos 9 multiplication table. Okay. What we want to do is 1 times 1 is equal to 1. 1 times 2 is equal to 2. Dot, dot, dot. And 2 times 1 is equal to 2, and 2 times 2 is equal to 4, dot, dot, dot. And 3 times 1 is equal to 3, and 3 times 2 is equal to 6, dot, dot, dot. 4 times 1 is equal to 4, 4 times 2 is equal to 8, dot, dot, dot. Okay? So, how we do write this program? We need two integer variable, okay? And these two integer variable will index the two for statement. And the first for statement is indexed by variable I, and delete this part, okay? And I is starting from 1 and end at 9, okay? Now, so up to this point, we can see that this pair of bit bracket will be executed 9 times. The first time I is equal to 1. The second time I is equal to 2, okay? Dot, dot, dot. Until 9, I is equal to 9. So totally, this pair of bit bracket will execute 9 times. Okay? Now, within this bit bracket, we can put another for statement. This for statement is indexed by variable j, and starting from 1, and the j is less than or equal to 9, and j plus plus. Okay? Now, please tell me how many times this for statement will be executed. How many times? This 4 is just one for statement. Inside this pair of bit bracket. Now we know that this bit pair of bit bracket will be executed 9 times. So this for statement will be executed 9 times. Okay? Now, this for statement have a pair of bit bracket, and this pair of bit bracket will be executed how many times? J is equal to 1 until each time, each iteration J is increased by 1, and until J is equal to 9. So this pair of bit bracket will be executed 9 times. For each time this for statement is executed. Compared to the previous point, I say this for statement will be executed 9 times, and each for statement will execute this bit bracket 9 times. So totally, this pair of bit bracket will be executed how many times? How many times? Will be 9 times 9 equal to 81. So this pair of bit bracket will execute 81 times. Okay? Now, suppose we have a variable. It's called counter. Counter is a variable which is used to count, okay? Each time we increase by 1. Each time we increase by 1. So before we go into this part of the program, we reset the counter into 0. Now in here, in here, we increase counter by 1. So outside for statement, okay, this is semicolon, not colon. Semicolon. Counter is equal to what? Counter. Okay? So this program is just keep counting how many times this most inside big bracket will be executed. Okay? Each time it executes, each time it adds the counter value by 1. It increases the value of counter by 1. And here, we exit this for statement. And this is called nested for. Because inside a for statement, we have another for statement. Okay? So let's rebuild it. And let's long it. Okay, so counter is equal to 81. So this inner part of the bracket will be executed 81 times. Okay, let's save it. Just for you guide to reference, we have this kind of we have this example. Okay. EX 10-2 02A. Okay. Go back to what we intend to do initially. We want to print the 9 cross line multiplication table. So what we're going to do is we print percentage D cos times percentage D. We don't want too many digits, so percentage 1D and a percentage 1D and a percentage and equal to percentage and most 2D. Okay? Now we have to put a column at the end. And here we print I and print J and print I times J. Okay, we print 3 values. The first value is using format of 1D with the value of variable I. And the second is percentage 1D also, and print the value of J. And then the last one, the third one, is percentage 2D because and 9 multiplied by 9 will give us 81. And 81 only have 2 digits. Okay, so the most number of field, the most number of space we need is only 2. So we put a percentage 2D here. And percentage 2D will be replaced by the value of I times J. Okay? Now, this for statement will be executed once, but this pair of bit bracket will be executed 9 times. And each time we print this guy, we print this string. Okay? So this string will be continued print on one line only because we want to have the result of all value multiplied to variable I. But after we print one line of the result of the variable I, we are going to jump to the next line to create a table. Okay, so we print a new line character here. So you will jump to the next line. Okay, so this we don't need this one. Okay, so we build and execute. So we got this one, and it's kind of messy because we print one line which is too long for our current character size. So supposedly we change the size to 18. Okay, and then increase this window. We can see this. Okay, 9 cross 9 table. But, okay, so this is this example. I'm using 2 for statement. Okay, let's say this program first. EX10-02B. Okay. Okay. In this example, we have a 4. We have a 4 inside a 4. Okay. Now, can we do this? Can we have a 4? And we have a 4. And we have a 4. Can we do this? Can we have a 4 inside a 4, which is also inside the third 4? This is okay. And how deep is this kind of structure can be? No limitation. As long as you can follow the logic, because the deeper of this kind of flow, the more difficult for you to trace your program. But there's no limitation on net. How deep is the net? Okay, no limit. Okay, no limit. As long as you want, but the deeper, the more difficult to trace your logic. So keep it properly. Another way to avoid this kind of next loop, next loop structure, too deep, is using function. Okay? And which the C's function we will introduce after the midterm exam. We can define our own function, just like printf. Okay? Just like printf, scanf, which we have seen. And the only difference is these two functions is defined by the compiler software company. Is written by software company. Is in the standard library. So you don't need to write it, but user or programmer can define his or her own function. Okay? We will come to that later. Okay? Also, so far we use for as an example on nested loop. Can we have a while statement? In a while we have a condition. Okay? And then this is the big bracket for while statement. So this is a complete statement. Okay? This is a complete statement. Now, within this big bracket, we can have another statement of for, which is also a loop statement. We can also have another loop statement called while. Okay? So this is also next loop. Okay. So the part of the repetition of repeat is this pair of big bracket. And each time this pair of big bracket is repeated, we execute the for first, and then we execute while next. And this is a loop, a for loop. This is a while loop. Okay? This is the first part is for loop. Okay? And outside this for loop and a while loop, we have a while loop. Okay? What we call loop is something we are going to repeat and repeat and repeat and repeat, repeat and repeat again and repeat again and repeat again until the condition is not satisfied. Okay? Until the condition specified by the while statement or do while statement or for statement, the condition is not satisfied. Okay? So nested loop structure can be any statement of while, of for, of do while. Okay? Okay, so we can have a while, and inside we have a do while. And do while we inside have another do while. Or inside a do while we have a for. Okay? Whatever you want, whatever you need. Okay? But most important I have to emphasize is the occasion of which loop statement you should use, or I should say which statement you use will be more proper. Okay? In fact, this kind of root structure can be translated and perform identical result. Which means if you write a 4 statement, you can change using 5 statements to do the job. Or you can do while. You can change your program by using 4 to do the job. Okay? Anything. And these 3 can be so-called interchangeable. Okay, they can be interchangeable. But for certain occasion, one is most proper and most concise. Most concise, more proper to use. When to use, okay? I should say, if you know how many times you are going to do this repetition, you should use 4 statements. You can count how many times. And if you have to check a certain condition first, then do the repetition part, you should use while. And if you, no matter what condition or no matter certain condition is true or not, you will do the job at least once. You should use do while. So do while will do the repetition once and then check the condition. Okay? So this is basically the occasion of choosing which loop statement to use. Now next, we are going to introduce a statement called continuous. 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 Okay? Now, what is continuous? Continuous this is a keyword, and it can be put inside a loop of those statements. For example, for supposedly, okay? We want to add 1 plus 2 plus no plus 3, we plus 4 plus 5 and plus 6, no plus 6 plus 7 plus 8 plus 9 and no 9. Okay? Until say plus 100. And what's the result? Do you see what kind of summation we are doing here? Is we are going to sum the value from 1 to value of 100. Which that are not the multiple of 3. We take off all the multiple of 3 from this summation, and we want to sum from 1 to 100. Okay? So, what are we going to do? How we write this program? Again, I and the sum, okay, and we are going to sum. We set the sum to 0 here. And then for I, starting from 1 until I became greater than 100. Now, within this form, we are going to do is do a little check. If I percentage 3, which means I is divided by 3, if the remainder is equal to 0, look out, we should not put one equal signs here. We should put double equal signs, because only double equal signs represent the condition check of the left side is equal to the right side or not. Okay? So if I percentage 3 means the remainder of I is equal to 3, it means it's a multiple of 3. Okay? It implies I is a multiple of 3. Once it's multiple of 3, we should skip the summation of this number. Okay, so we use continuous. What's continuous mean is we skip the statement after continue until the end of right parenthesis. But not parenthesis, right big bucket. Okay, until here. This part will be skipped. No matter how many statements is in this part. Okay? So the part I highlight is the part we are going to skip. Okay? Skip. Jump over. Omit. Okay? Ignore those statements. Do not execute this statement. So when we see this continuous. Okay? So, but if this condition is not true, it will continue to the next line. And the next line we are going to do is sum plus equal to I. Okay, so this is continuous. The function of continuous. You skip this statement. In this example, you skip only this statement. Okay? And outside the whole statement, we have a print outside for loop, and sum is equal to percentage D slash A, and we print sum. Okay? So we get this one. So sum is 3367, okay, 3,367. Now, supposedly we want to print out the number we add to the sum and skip the number we are not adding. So we're using a technique called flag. Let's save this version of the program first before we continue our example. So we call it -3 EX10-3A Okay, 03A. Okay, let's go back to our example. Suppose we are going to print something like this one. Okay, something like this one. Okay, but this part we are not going to print. We are not going to print. Okay, so how we do this? Okay, just do a little thing. Yes, we say we set a flag. We use a flag to indicate if we are in if we print the first value already or not. So now here, once we skip or continue in fact means skip the rest of the statement inside the loop. The actual meaning of continue, which is say skip the rest of statement within the loop. Okay, this is what continuous actually means. Okay, now if flag equal to 0, okay, it means we have not print anything. Okay, at this time we just print percentage D. Okay, and print the value of I. Now, once we print the first value, the variable flag will be turned on by setting the value of 1. The flag equal to 1. It means the first value has been printed out. So the following value, before the value is printed, we should put a plus sign before. So else is what? Is printf. Okay. Printf. And before that, we should put a plus sign. So the difference between this printf and this printf is one with plus sign before, one is without plus signs. Okay? Now, and then we sum the value of I into variable sum. Now, we take out the outside the loop here. When we go out this for loop, we should place an equal sign and a percentage D. Okay, and this percentage D is replaced by the value of variable sum. Okay, so let's see how we got. Okay, so this is how we got. Okay, 1 plus 2 plus 4 plus 5 plus 7, and no 9 plus 10, and until 3,367. Okay, so it just looks like a handwriting mathematical computation. Okay? In order to do this, you need a check of whether the first number is printed or not. Because in this result, in this printout result, 1 don't have a plus signs before, but the rest of the number all got plus sign before. Okay, so you have to design your printout to make it much more look like a mathematical equation. Okay? So this continue, we skip this whole thing. For those number that are multiple of 3, we skip all this part. Okay? No print and no summation. Okay? No sum and no print. This part is totally omit, totally ignore when this continue is executed. Okay? Too bad we run over time. Okay, so let's take 10-minute break now.